Okay, so we're focusing on relating standard and factored form. So, right here, we have two forms of a quadratic. Okay? What we're going to do is we're going to show how both these forms represent the same graph. This form here, does anyone know which of this is called? Is that the standard or the factored form? Anyone know? Standard. Good. This is our standard form. Okay? Which means that this will be our factored form. Now, we're going to talk about moving from one to the other. If I'm going from standard to factored form, what is it that we need to do in order to do that? We need to factor it. Very good. So like we said, when we go from standard to factored form, we are factoring, which we've gone over. What if I'm doing the reverse? If I'm going from the factored form to the standard form, what do? We expand. Yeah, expand and simplify, they call it. So, what we're going to do is we're going to talk about how factored and standard forms help us with our graphs to start. Okay? I've given three different major parts of a quadratic. Okay? This part, the highest part, is known as what? Anyone remember? That's right. That's called the vertex.
Boom.
Okay. Kind of is the middle of the vertex. The highest or lowest point is known as the vertex. Now, these 2 points down here, anyone know what they would be called?
Zeros.
Zeros, yeah. There's another name for them. What line are they?
Roots. X-intercepts.
Yes, x-intercepts. You're right. They're also normally called zeros, and we'll talk about why it's called that, okay? So these are x-intercepts. Yeah, we'll get to that in a second. And there's a purple point here. Anyone know what that point is called? Yeah, exactly. It's going through the y-axis, so we call it the y-intercept. Okay. Now the axis of symmetry, because that was good that you brought it up, it just happens to be the middle. Cuts right through the vertex, and it's on the x value of the vertex. So let's actually write down what these coordinates are. Our vertex here is at what point? What's the coordinate of that? -1, 9. Good. The x-intercepts, one of them is at negative, I don't think it's 5, it's 4. 4, 0. And this one is at 2, 0. Good. And our y-intercept is at what point? 0, 8. Good. Okay, so we have these coordinates. What we're going to do is we're going to try to build our equations from this. Okay? Before, what we normally do is we'll get an equation and then they'll ask us to graph it. We're going to try to do the reverse here, hopefully to help with our understanding. Now, there's some major points in both that'll help. It'll be easiest to create the factored form from our graph. Okay? Now, there is one part of the standard form where we can plug a value in right away, and it will satisfy one of these letters, A, B, or C. Does anyone happen to know which one does it represent? Or which letter? C. What does C represent? Anyone know?
The y-axis of the vertex. I don't know.
Ah, that's the one we're looking for. Our y-intercept is essentially what our C is in standard form. So, as a side note, our y-intercept is at what value? 8. So when we go to standard form, our C should be 8. Okay? Just to keep that in mind to help us. Also, which way is this graph facing or opening? Downwards, which means our A needs to be at least negative. We don't know the actual value of it, but we do know that the A value is going to be negative. So those are two things we're going to keep in mind when we go through the factored form and then relate it to the standard form after. Now, in our factored form, we have an A, and we also have that in the standard form. Those should be the same number for what we're doing here. Okay? Our R and our S are actually our intercepts. Okay? So we're going to take those two intercepts. Both values, one represents R, one represents S. So, and it doesn't matter which we call which. The first one we'll say is the value of +2. And the second one is -4. We're going to plug those in for R and S. Okay? So we have f at x is equal to, still have an A value, And then the negative still stays there. It is negative, and the r value is positive 2. Okay, and I'm going to write it as positive 2 just to show you how things are going to change. The next one is x subtract negative 4. Okay, that's right. So that's going to change those values when we get in here. So our a we still are as unknown. Our x should be minus 2. And our other x should be plus 4. Okay, so keep in mind that when our x values only have a 1 in front of them, these numbers are directly related to the x-intercepts. And that changes a little when the x value changes. We'll talk about that after. Okay, so I need to recreate this formula here. Well, we've dealt with the r and the s. We still don't know the a value. Okay, now the f at x technically stands for our y values on a graph. Okay, so what we're going to do is we can technically take any y value along this graph, or sorry, any actual point. For instance, though, this point here might be really hard to deduct exactly what it is. It's between points, and we'll have to give it a decimal. It may not be exact. One value we do have that is going to help us out a lot is the vertex. We actually have it crossing at an exact whole number point. Okay, so we're going to take the vertex, and it doesn't have to be, but it will help with our understanding. We're going to take the vertex values, the x and the y value of the vertex. Okay, that's a 9, by the way. And we're going to plug them in. We're going to plug in the y value for f at x, and we're going to plug in the x value, negative 1, for both of the x's. When we do that, we'll be able to isolate our a, exactly. So our y value is 9. Is equal to, I guess I should have used a different color, but a, our x values are both going to be what value? Negative 1. And because there's 2 of them, it doesn't matter. It's still going to be the same value. Okay? Plus 4. So, now all we have to do is follow our bed mass and create our factored form equation. So we have 9 is equal to a. This is negative 1 minus 2. What will that give us? Negative 3. And we have a negative 1 and positive 4. What that will give us? 3. Okay, this is very important here. What you guys should have realized from this is both the absolute values, okay, or the unit values are the same. In other words, it's the same distance from one x-intercept to the middle as it is from the other x-intercept to the middle. Okay? So in other words, x-intercepts, or the axis of symmetry, are directly between what two values? Sorry, the vertex is directly between what two values? Your two x-intercepts. And that's very important for when we do this the other way. Okay? And we're going to talk about that because there's a formula called the axis of symmetry. Okay, so we're going to do a little side note right now. The axis of symmetry is known as r plus s divided by 2. Okay? The r and the s are our two x-intercepts. Okay? We'll take negative 4, and our r is 2. And we're going to add them together. What does that give us? Okay, that's going to give us negative 2 over 2, which is negative 1. So, just as a check, our axis of symmetry, this line going through the middle, and our x value of the vertex are both what value? Negative 1. Negative 1 is directly between those. Okay, so keep that in mind because that's going to come in very handy for us. So now that we've done that, 9 is equal to a. What is negative 3 times 3? Negative 9. How do we get a by itself? That's right, we divide both the sides by negative 9. These two create a 1 or cancel out. And we're left with a of a value of what? Negative 1. So let's write the factored form of this equation. The factored form is f at x is equal to, the first letter we usually write is our a, so we write negative 1. Yep. Okay. Is it x plus 2 or minus 2? That's right, it's minus 2. And x plus 4, okay? So we've created the factored form of this. Keep that in mind. This was to find the factored form from the graph. Now, I also need the standard form. What am I going to have to do in order to find the standard form? We're going to have to expand this, okay? Which is FOIL. Exactly what FOIL is, okay? We'll leave the 1 till last, and we'll FOIL the first part. So like we said, we're going to FOIL this. So our f at x is going to be equal to, I'm going to actually leave the negative 2 last. I'm going to do FOIL first, or sorry, the negative 1. Negative 1 on the outside, let's do FOIL. X times x is x squared. X times 4 is positive 4x. Negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. Okay? We simplify our two middle terms. We still have the negative 1 on the outside. X squared minus 2x minus 8. I got to distribute the negative 1, and we're going to get negative x squared plus 2x plus 8. What did we say the y-intercept or the c value in standard form was going to be? Yeah, and we said the a value is going to be negative. Those both fulfilled this. Okay? Now, as one side note, because it is very important that you know how to do this the other way, if you're given factored form, so they give you this form, and they ask you to find the x-intercepts, so they don't have a graph. The way we find x-intercepts are we take the factored form, which we created, f at x is equal to negative 1, x minus 2, x plus 4, okay? And we set f at x equal to 0, because it represents y. And we know that x-intercepts are when y is equal to 0. When we go through the x-axis, y is equal to 0. So, 0 is equal to negative 1, x minus 2, x plus 4. And we want to isolate these. We're multiplying these values. Well, I'm going to try to move that negative 1 to the other side, so I divide both sides by negative 1. When I divide 0 by negative 1, what do we get? Just 0. These guys cancel out. We're left with x minus 2, x plus 4. Now here's the tricky part. Technically, I'm multiplying this bracket by this bracket, so it's a term by a term. When we multiply, our value has to be what? We're looking for something equal to 0. There's only one number I can multiply by to get a 0. 0. I can only multiply by a 0 to get a 0. So that means one of these brackets must equal 0. We just don't know which one. Okay? Whether it's this bracket or it's this bracket, they both must equal 0. So we're going to test for both, and we're going to find two answers. We split the equation, okay? And we get 0 equals x minus 2. And 0 equals x plus 4. Okay? I don't need the brackets actually anymore. And we find x. So when I move to the other side, what do we get? 2. And when I move 4 to the other side, what do I get? Is that exactly what our x-intercepts were? That's exactly what they were. So if you're given factored form, this is how you find x-intercepts.